Hello, and welcome back to my video series, Getting Smart About Artificial Intelligence. Today, we are going to cover concept learning and classification. In this video, I'll give you some simple explanations and examples for each of these topics, and show you how both concept learning and classification can benefit you. Let's start with concept learning. Concept learning is generally defined as the acquisition of a definition of a general category from given sample positive and negative training examples of the category. Now, I know that sounds a bit confusing, so let's explain with some examples. Take a look at this photo of the 2015 Duke men's basketball team and consider this question. Is Coach Mike Krzyzewski tall or short? While you were thinking about your answer, I'll tell you that tall and short are concepts. It is something that we can recognize even though we don't have a static definition for it. And we can recognize it even without an exact measurement. This is because throughout our lives we have heard certain people referred to as tall and certain people described as short. All of those examples are stored in our brains and allow us to create loose definitions for these words. We can train a computer the same way. So let's go back to my question. Is Coach K tall or short? Well, most people I surveyed while showing this photo said he was short. This comes as no surprise. Coach K is the shortest person in this picture. However, Coach K is 5'10", and according to the CDC, Coach K is actually taller than the average US male. This brings us to another important point about concept learning. Concepts depend on the context. Within the context of his team, Coach K is short, but compared to all men in the US, he is tall. When we start thinking about the applications of this, we can remember that the context can be gained from the vast sums of data that we can collect. So any training data set becomes our context, and we can derive some concepts from that data set. Concept learning makes data more accessible to human analysts, who can ask questions in natural terms that we're familiar with, like tall or short, and the computer will translate our conceptual words into quantitative queries based on that trained dataset. Not too far from concept learning is classification. This is where a machine can use data to determine whether something belongs in one group or another. Let's pretend I invited you over for a dinner party, and you, being a great guest, offered to help me unpack my dishwasher. You unpack these 4 glasses, and I tell you that these glasses should go in this cabinet. But for reasons unexplained, I have to run, and you have to figure out on your own which shelf each glass should go in. Think you'd be able to manage? I think so. And a computer would too. A human is likely able to make complex connections tied to the type of drink that goes into each type of glass. But we could use an even simpler method with a computer. The first thing the computer would need is data. So I'm going to capture the height of each of the glasses on the shelf already, and the width at the widest point of each of the glasses already on the shelf. This represents my training data. For simplicity, I've added a plot of the heights and widths in this chart. The green dots represent the top shelf, the purple dots represent the middle shelf, and the blue dots represent the bottom shelf. Using this training data, I will say that each glass that I pull from the dishwasher should be put on the shelf with glasses similar to itself. If I implement this rule, I come up with this. This is a visualization of my model. I have learned from all of the existing glasses on the shelf, and I now have a framework for deciding where each new glass should be placed. Let's see how well this works. Let's start with this mug. Its height is 4.5 inches and width is 5 inches. If I were to check this against my model, let's see what it says. Well, this is in my middle shelf territory. Does that look right? Yes, it does. This mug ended up with the other mugs. Well, how about this glass? It's 6.25 by 3.5. When I put that into my model, it's close, but it's in the bottom shelf territory. And we can see that that's the right choice. Now let's try this shot glass. That's 4 inches by 1.5 inches. Our model tells us that this goes on the top shelf, which is where the other shot glasses are. Lastly, our wine glass. This has a height of 9 inches and a width at its widest point of 4 inches. Our model also has that on the top shelf, which is where it belongs. Classification can be used anytime you have a "what shelf does this go on" problem. As long as you have enough of the right data, you can use it to divide anything into multiple groups, like determining whether an email is a phishing email or not, or guessing whether a guest Wi-Fi user is a visiting student or a visiting faculty member. The key with classification as a supervised form of machine learning is that you need a training dataset, which captures the differences of each group. Once you have that, you can start exploring the possibilities with using AI to divide a dataset into different groups. Thanks for taking the time to watch this video. If you thought it was helpful, please hit the thumbs up button below. If you want to keep getting some simple explanations of AI and how you can use it to make intelligent, data-driven decisions, keep watching this series. Next up, we'll discuss grouping.